So here's how you can solve a linear first-order differential equation. Now before we get started, make sure these practice problems here make sense. These are practice problems that involve the natural log and integration and the rules associated with them. You're going to need to know these in order to solve this problem we're going to do, so definitely make sure these practice problems make sense. So if you want to pause the video here, feel free to look over these real quick. Alright, so let's say we have a differential equation like this. Now in order to determine if you have a linear first-order differential equation, it needs to fit this format right here. And as you can see, we actually fit this format perfectly. We have our function p of t right here and our function q of t right here. So we know that we fit this linear first-order differential equation. So now that we have p of t and q of t determined, all you need to do is take this and plug it into the two equations down below. You first find your integrating factor, which you can plug in p of t for, and then when you find this solution here, plug this into your equation down here, and that will give you the solution to the problem. So I'm going to take this p of t and plug it in, which is 2 over t with respect to t. So now what I'm going to do is integrate 2 over t using these steps right here. Again, hopefully the problems on the first page made sense because you're going to need to use the natural log rules to do this, but you should end up with t squared as your integrating factor. So now that you have your integrating factor, you can take this and plug it into the two places you see I of t in the solution equation down below. So t squared will go right here and right here. Now all we need to do is plug in q of t, and we see q of t as this expression, so I can take that and plug it into the equation down below, and conveniently the t squareds will cancel, giving me the antiderivative of cosine of t with respect to t, and then we have that all multiplied by 1 over t squared. Now the integral of cosine of t is going to be the sine of t. And notice for this case, we do add a plus c because this is the solution we're calculating. And once we find this plus c here and we integrate this function, we can take this 1 over t squared and FOIL it into this expression, giving us sine of t over t squared plus c over t squared as our solution. So that's how you can solve a linear first-order differential equation.